The next hypothesis principle is about p-hacking. P-hacking is a procedure that erroneously rejects the null hypothesis only 5% of the time. So it is like 5% of the experiments which is being conducted, it checks out for the output whatever it is needed. Better let's start with the code. So we'll create here as p-hack.py, and here we'll start with the hypothesis analysis, starting with the import of random. Then comes the definition, which is run underscore experiment. And after that, we'll start with the hypothesis analysis as return value as random of random. So this is like calling for the library random and generating a numbers of random, which is less than 0.5. After that, we'll specify the range, and that is for in range of 1000. Now we'll create out our next experiment, which needs to be subsidized, is about the fairness results. So we are just checking out over here that to find the significant results through the hypothesis analysis and the data set, like one of them will definitely appear to be significant. So my function now is definition for the rejection, because we are rejecting for the 0.5 analysis. So that is reject fairness with the value or with the parameter as experiment. And after that, we'll mention here as the number of heads equals length of an array value with a flip of in experiment of if flip value as. So this is the array value which is to be taken, and it will return a value, that is return number of heads less than 469 or number of heads greater than 531. So this is the range which I need to specify. So this should be with the fairness analysis calculated with a range from 469 to 531. After this, I'll just seed out these results with the functionality over here as random.seed 0. This means it initializes my experiment from the beginning, and now it will say experiment equals an array value of run experiment with the value for in range of 1000 with the value as number of rejections equals length of experiment in experiments if reject underscore fairness is taken in the value of experiment. So this is being calculated, like this indentation is being done properly. Now after this, now we'll run the output over here as Python p-hack.py. So it gives the possibility over here. So this is the number of rejections from the 100 criteria is 46. So what does this mean? That if you are setting out a significant result over here, just going on to our code. So here it means that if you are setting out a significant results, you usually can test enough hypotheses against your data set, and one of them will almost certainly appear significant. So this is sometimes called as p-hacking and is in some ways a consequence of an interference from p-values framework. So which is a good analysis when it comes to the hypothesis theorem. The next we'll understand is about the Bayesian interface, which is also a procedure which looks for the involvement of probability statements about the various tests. So next chapter is all about the particular interface with respect to hypothesis.